In Chapter 3, we're going to learn how to use functions in programming. The idea is if you have a program that starts to get long and complicated, or if you have a task that you need to do several times in a row, then you can build a function which then you can call to do that task. And it makes the code a little easier to read, and it saves you from having to do repeat work. So we're going to look at this idea of functions in Python in two different ways. First, there are some built-in functions which you can bring into Python using an import command, and then we're going to talk about how you build your own functions. So looking at the first example, Python has a lot of mathematical functions built into it. Python is used a lot by physicists and engineers and data analysts, so it's not surprising that there's a fair amount of math built into it. But to access those mathematical functions, you have to import a module called math. And the way you do that, or a way to do that, is pretty simple. It's import math. And when you import math, you get a lot of functionality. You can get the trig functions, the sine, cosine, tangent, exponential functions, e, ln, etc. Now, the trick is that when you do this, those functions, if you do the import math command as is, are identified with a math module. So if I wanted to compute, for example, pi over 3, pi is defined in the math module. So to get to it, I have to do math, the module, dot pi, and then I can divide it by 3 and assign that to a variable x. If I want the cosine of pi over 3, I can plug x into cosine, but again, cosine is defined in the math module, so I have to do math dot cosine of x. So that says go out to the math module and look for the function cosine of x. Similarly, if I want the exponential function, if I want e to the first power, which should just give me e, it's x above 1. But that, again, is in the math module, so I do math.x above 1, and that gives me z. And if I print those three out, I can already see them on the bottom of the screen, but if I print those three things out, pi over 3 is a little bit over 1. That's not surprising. Pi is close to 3. Cosine of pi over 3 is indeed 1/2. Notice there's a 1 out here on the end. That's an interesting math or computer science topic called about round-off error, but cosine of pi over 3 is indeed 1/2, and e is 2.71828, etc. So, two things. By importing modules, you can gain more functionality in Python, and then you can get access to functions, which take inputs. Some functions take inputs and do something with them, and some functions, those are actually called procedures. They don't give you anything back. In this case, cosine of x, for example, is a function which takes an input and gives you back an output, and those are called functions. Okay, it turns out that there is another way to import stuff into Python. You can, instead of doing import math, you can say from math import, and the star in this case means everything. So we're going to import all the functionality from math. They could be, there may be reasons not to import everything. If you had built your own cosine function, for example, you wouldn't want to import maths, but in this case, that's not an issue. The advantage to doing the import this way, instead of just saying import math, is that you don't have to use the math dot notation. So we've imported all the functions from math, and now we can just say x is pi over 3, y is cosine of x, z is x above 1, and run, and we get the same output. Okay? So, what if we wanted to build our own functions? So we are going to write a little program to build a knock-knock joke. Okay, so here's the first iteration, knock-knock version 1. We're just going to print the knock-knock joke out. Print knock-knock, who's there? Canoe, canoe who? Can you help me with my homework? And this actually, I mean, it seems silly, but I pulled this knock-knock joke off from a web page, and that web page underneath was written in a programming language called HTML, and there's code underneath to print the knock-knock joke out. It's not just printing, it's not just typing text. You actually have to tell the web browser how to print things out. So there actually is code to put this knock knock joke up on the web. So there is, some practicality to this assignment. Okay, so I noticed that there's some commonality among knock knock jokes. It's always knock knock, who's there? So if I want to have more than one knock knock joke, I'm always going to have to do this. So maybe what I want to do, I didn't run this, so I'll run this. Oops, I ran import math version 1. What I wanted to do is run knock knock version 1, which is not in my list. So let's go up here to run. Run. We'll run knock knock version 1. There we go. So we print the joke out. Knock knock, who's there, canoe, etc. Okay, so if I wanted to build more than one knock knock joke into my little program, I'm always going to have to say knock knock, who's there. So let's go over to knock knock version 2. So notice that now I've got two new things here that start off with def, and I've got a def knock knock, and I've got a def who's there. This is how you build functions in Python. So there's a few things to notice. When you're going to build your own function, well, actually in these cases, these are what are known as procedures because they don't give any values back, but anyways, they should go at the top of your program, not at the bottom. They start off with def, define, means we're defining a function, the name of the function, parentheses, a colon, and then the new line are the commands inside of your procedure or function. So we have two of these defined here, def knock knock and def who's there. And they do something very simple. Def knock knock just prints knock knock, def who's there just prints who's there. Now, we can call these. If I want to print out knock knock, I can just call the function knock knock. Sorry, procedure, it doesn't return a value. I can't assign knock knock to anything. So it's a procedure. I can call who's there, and then in the end, I'm going to print out the canoe who can help me with my homework. Notice I'm doing it in one print command now. Instead of having several print commands, I'm putting the /n in there, which gives you a new line. So if I run this, so we're going to run knock knock version 2. Well, apparently I can only have so many things in here at one time. I just keep knocking out the thing that I want. So run knock knock version 2. We get the exact same output. So here's what happens. Python comes into this program and sees the author's cook, doesn't do anything, sees these defs. It doesn't actually run those. It just makes note of the fact that there are procedures or functions up here at the top, gets the name of them, and then proceeds on. It doesn't start actually executing things until it gets down to here. So it gets past all the procedure and function definitions. So in this case, the first thing it does is it runs knock knock. So it calls knock knock. It comes down here, sees knock knock, calls knock knock, comes up here to this def, goes inside and says, what do I have to do inside this procedure? Oh, I have to print knock knock. So it prints knock knock. When it's done with the last line in this procedure, it goes back to where it was, goes back to here, says I'm done with that, go to the next line. This calls who's there, goes up to who's there. We see that in who's there, there's only one line to execute. It prints who's there. It's finished with that after that line. You can tell by the indentation. So notice that when you have a new def, these lines inside the def are indented. And they actually have to be, well, they're supposed to be indented 4. See, it's yelling at me because I haven't indented them by 4 spaces. That's actually a Python thing. This will run without indenting 4, but it'll yell at you. So I'm going to put this back to 4 spaces of indentation, and it'll stop yelling at me. And over here, there's boxes over here are warnings saying you've goofed something up. So I'm going to, by putting this to 4 spaces of indentation, it's going to stop yelling at me. Notice I have another thing yelling at me. Expected 2 blank lines, found 1. So from the start of your program to the first def, you're supposed to have 2 blank lines. So I just got rid of a bunch of boxes over here when I did that. Expected 2 blank lines, found 1. So I need 2 blank lines between my 2 procedures. Sorry, got sidetracked. Okay, so we've printed who's there. This is indented inside of the procedure, so it knows these are the lines of code in here. So anything that's indented like this will be inside the procedure. And when I get to here, this is non-indented, so this is not inside the procedure. I know there's a blank line here, but technically you wouldn't have to have that. It's just the fact that this is not indented. Okay, so we've called who's there, it printed who's there, and then we print Canoe, who, can help me with my homework. Okay, if we wanted to get fancier, notice that whenever we put a word here, the next line is always going to be that word or phrase followed by space and who. So if we wanted to get fancier, we can go to Knock Knock version 3. Oh, sorry. I skipped ahead of myself. We always print Knock Knock who's there. You actually don't need two procedures to do that. You can put both of these lines in one procedure. So Knock Knock version 3, instead of having two procedures, we just have Knock Knock intro, which puts two print commands. Notice that they're both indented. Notice that I'm getting yelled at over here. So expected two blank lines, found one, get rid of that. Indentation is not a multiple of 4, so I've indented too much. Doesn't like that. And okay. So I've gotten rid of those bad things. So in this procedure, we have two lines that are both indented. It's going to execute both. So the program will come in, see the author, see a procedure definition, say, okay, I'm going to make note of that, come down here to start executing code, say, oh, I need to call Knock Knock intro. It'll call that, it'll come up here, it'll execute the two lines of code that are now inside this procedure, print Knock Knock who's there. So let's run this. Okay, so we're running Knock Knock version 3. So it prints Knock Knock who's there. So these two lines here that are printed are actually inside there, and then there's the print Canoe who. Okay. Knock Knock version 4 was what I was alluding to earlier, that we noticed that anytime I put a phrase here, that phrase is followed by Canoe who. Oh, you know what? I've got this wrong. I'm actually talking about the homework that you have to do. This is something else. This is where I want to print out two Knock Knock jokes. And so I have two Knock Knock jokes. They both have Knock Knock who's there, but I want to separate them by a line. So here's what I've done. I run Knock Knock intro, same thing as before. So that gives me the Knock Knock who's there, and then I print out my joke. Then I want to separate the joke by some lines. So I call separator 20. Now, separator, notice this has something we can input into it, a 20. So I can put a 20 in here. I can actually put any number I want. So here's how you define then a procedure or a function with an input. You put it inside the parentheses. So separator is defined up here, and it takes a number, and I've called that number n. You can put any variable you want there. And then it immediately defines x to be a string with just a minus sign times n. Now remember that in strings, if you multiply n, it's just going to repeat that string minus sign n times. And then it's going to print that string, x, which is just a bunch of minus signs, and then it adds to that at the end of \n. So it puts a carriage return, or puts a new line on the end of it. So let's see what happens when we run this. Knock Knock version 4. So we get Knock Knock intro, Knock Knock who's there. We get the print Canoe who, can you help me with my homework? That's all this stuff. That goes down to a new line. Then separator is called. Separator comes in and says, I want 20 versions of a minus sign. So it prints out 20 versions of a minus sign. Adds to that, or concatenates is the word we use, to that string a new line. Kicks us down to here. We call Knock Knock intro again. Knock Knock who's there. And then we get any who, anyone you like. So in this case, we've used the procedure Knock Knock intro twice. We didn't have to type out Knock Knock who's there all the time. So if we had a bunch of Knock Knock jokes, then we can just keep calling Knock Knock intro. We can keep calling separator. and have that functionality built in. We can actually make that line longer if we make this separator 30 and run this. Then what happens? The separating line gets longer. We put in more minus signs. So the idea again with functions is to break up the work. Hopefully this becomes more readable with hard code. So you say knock knock intro, and that gives you an idea of, oh, there's going to be an introduction to the knock 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 joke. Then we print out this stuff. In the homework that you're going to work on, you're going to change this to become a procedure that says, okay, what's the line, what's the punch line, and then you're going to write a little procedure to print that out. And so then you can just have knock knock intro, knock knock, or the answer or response or whatever, and this whole thing can just become a procedure that you can easily print out knock knock jokes. So maybe not the most useful thing in the world, but I think maybe a nice introduction to procedures. And in the future chapters, we're going to get into functions. Functions are things that you're going to come in here, maybe compute some stuff or do some things, and then send a value back to the original program. An example we've actually seen of that is something like cosine, where this goes off, it computes a value and returns a value back, and we can assign it to another variable y. Okay, so now we're going to work in class on writing some of your own procedures.